Artificial intelligence may sound complex, but it all begins with a few simple ideas. In this video, we'll uncover the key concepts that power every AI and machine learning system called features, labels, epochs, overfitting, and underfitting. Think of features as the clues, labels as the answer, epochs as the practice round, and overfitting and underfitting as the mistakes models make when they don't just land the right. By the end, you'll see how these building blocks connect raw data to real intelligence. So stay tuned because understanding these concepts is the first step to mastering AI. Let us start with most important building block of AI called features. Features are input variables, the signals that describe your data. Think of them as the ingredients in a recipe. Better ingredients make a better dish, and in AI, better features make a better model. For example, when predicting house prices, features can be the number of bedrooms, square footage, or location. In images, features are pixel values, colors, edges, or textures, things that help classify what is inside a picture. And here is the golden rule: choosing the right features often matters more than algorithm itself. This is why feature engineering is one of the most powerful skills in AI. Now that we know features are the inputs, let us talk about labels, the outputs. Labels are what we want the model to predict. If feature are the ingredients, labels are the final dish we are aiming to cook. For example, in spam detection, the label is either spam or not spam. In stock forecasting, the label is tomorrow's stock price. And in healthcare, the label could be disease or healthy. Simply put, features are what we know, labels are what we want to know, and together they form the question and answer field that makes AI smart. AI doesn't learn everything in one go, it learns through repetition. An epoch is one complete pass through the entire dataset, but one pass is never enough. That's why we train models over multiple epochs, allowing them to slowly adjust and discover patterns. For example, with 10,000 training samples or pi echoes, the model actually sees every sample 5 times, getting better with each round. But here is the catch. Too few epochs and the model doesn't learn enough, that is underfitting. Too many epochs and it memorizes the data, that is overfitting. The secret to powerful AI is finding that sweet spot in between. Overfitting happens when an AI model learns too much. It doesn't just learn the real pattern, it also memorizes noise and random details from the training data. As a result, it performs great on practice data but fails when faced with new data. Think of it like a student who memorizes answers without understanding concepts. They score high on practice tests but fail in real exams. That is overfitting, knowing the answers by heart but not truly understanding the subject. How do we recognize overfitting? It shows up as very high accuracy on training data but poor accuracy on test or real world data. In short, the model has memorized instead of learned. So, what causes it? Models that are too complex, training for too many epochs, or skipping regularization techniques. And here is how to fix it. Use regularization like L1, L2 or dropout. Add more diverse training data. Or stop training early when validation error starts rising. The goal is simple. Train a model that doesn't just ace the practice test but performs well in the real world. Underfitting happens when a model is too simple to capture the real patterns in the data. It's like a student who barely studies and give generic answers, failing both practice and real exams. The telltale sign of underfitting is low accuracy, not just on test data, but also on training data. In short, the model has not learned enough to make sense of the data. Underfitting happens when the model is too weak to capture the real patterns in the data. There are three big reasons why this happens. The model is too simple, for example, using linear regression on highly complex data. The model has not been trained enough. Too few epochs mean it didn't get enough practice. Or the features are poor, irrelevant, or missing inputs stop the model from learning properly. So, how do we solve it? Use a more complex model, train longer with more epochs, and most importantly, improve feature engineering by adding the right data with domain knowledge. That is how you turn an underperforming model into a smarter one. Now let us put everything together with a real world example predicting customer purchases. First, we look at the features, things we already know about a customer like age, income and browsing history. Next comes model training. The model goes through multiple epochs, learning patterns while avoiding the traps of overfitting and underfitting. Finally, we predict the label. Will the customer buy the product? Yes or no? And here is the golden rule. Balance is key. Train long enough to capture real patterns, but not so long that the model memorizes specific customers instead of general buying power. This balance is what makes AI predictions powerful and useful in the real world. To truly unlock your AI potential, you need to master the fundamentals. These five concepts, features, labels, epochs, overfitting, and underfitting are the foundation of every AI system. They give you the knowledge to understand why models behave the way they do. They give you the language to speak about AI with confidence. And most importantly, they give you the power to build AI solutions that deliver real results. Remember, master the basics and you will be ready to shape the future of AI.